Assalamu alaikum. I am Dr. Sayyid Sajjad Hussain Rizvi, and today we are going to have a seminar on research trend in artificial intelligence. Before proceeding further, I would like to take this opportunity to introduce myself. I did my bachelor's in computer systems engineering back in 2005. Then I did master's in telecommunication. I also did another master's in business administration with a specialization of marketing. I did my PhD in machine learning and image processing. I have been associated with the academics for about last 16 years. Currently, I am associated with Shahid Zulfikar Ali Bhutto Institute of Science and Technology as an associate professor. Previously, I was associated with Hamdard University, Pakistan, as chairman and associate professor, Department of Computer Engineering. I was also associated with Ikra University as chairman and assistant professor, Department of Telecommunication. Beside the academics, I'm also actively involved with the local industries of Pakistan, such as transformation professionals and Technosource Pakistan. And indeed, it is very encouraging to see that the Nal University of Science and Technology is taking a very active initiative to participate and collaborate with the other universities around the globe. This collaboration is not actually limited to the academic and the research excellence, but it also promotes the flow of learning between the Nile University and the universities around the globe. The agenda of my seminar is: first, I will brief you about the basic fundamentals of artificial intelligence, machine learning, and deep learning, in which I will brief you about what actually is AI as a big picture, how machine learning actually relates with the deep learning, sorry, how machine learning is related to the artificial intelligence, and likewise how the deep learning relates to the artificial intelligence. We will also discuss about the intelligence solution searching methods, which is actually the classical AI. And subsequent to the intelligent solution searching methods, we have the machine learning in our agenda, and we will discuss how machine learning can predict and classify the real world scenarios. Subsequently, we will discuss about the deep learning, like what are the constraints and limitation of a machine learning that could be handled with the deep learning. Finally, I will brief you about some of my research work in the area of artificial intelligence, and they are actually the recent work in the year of 2020 and 2021. Now, the first thing is, why actually one need artificial intelligence? Actually, the term artificial intelligence is primarily helps to take the decisions. So eventually, what we need to take a decision. There are two methods for taking a decision. The first method is we call as a informed decision, and the second method is called as a blind decision. If we take a blind decision, that is without any knowledge, without any information, or without any data, if we take such decision, that decision will be termed as a blind decision. There are 50% chances of success in that decision, and there are 50% chances of failure in that decision. So, in order to improve the chances of success and reduce the chances of failure, we need to make a decision, much informed decision. For example, there is a pathway for informed decision that starts from the data. We have we first need to acquire a data about that particular domain. We know that a data is a raw facts and figures. They do not have any information, or they do not have any illustrations. It's just raw facts and figures. We first need to transform, or we first need to process this data into an information. So there are some set of procedures, there are some set of mathematical methods, there are some set of statistical methods that could help to transform a data into an information. So the first step is we have the data, we process that data, and then after processing, that data becomes information. When this information is fed to a brain, that could be a human brain, or that could be a artificial brain, that where the comes the artificial intelligence is. That brain is equipped with the past experience and the authoritative capability. Using the past experience and using the computational capacity, this information will be transformed into a knowledge that is an actionable attribute. Subsequently, this knowledge will further translate into a decision. So, the conclusion is if you need to make a decision, there are two methods to take a decision. First, you take the blind decision. So, in order to take the blind decision, there is no need to have a data, to have information, to have the knowledge. But that blind decision would have 50% chances of success and 50% chances of failure. And let me tell you, this 50% chances of failure is a lot. However, if we take an informed decision, so in order to take the informed decision, first we need to acquire the data. The first step for informed decision is to acquire the data, then process the data so that it becomes information, then analyze that information using the past experience and the knowledge so that it translates into a knowledge, and then we use that knowledge to make a decision. This is actually the pathway towards the decision. If we are using human at this place, we call it a human intelligence. However, if we are using some algorithms, if we are using a computer, or if we are using a machine for making or for transforming the information into a knowledge, we call it artificial intelligence. Primarily, there are three fundamental subsequent scope of artificial intelligence. The classical artificial intelligence is mainly refers to as the search strategies. In the search strategies, we have different algorithms. In the search strategies, we have different algorithms. Mainly, they are classified as informed search and uninformed search, such as the breadth first search, the depth first search, the best first, beam search, bidirectional, uniform cost, iterative deepening, informed search, heuristic search. These searching methods are found to be efficient only for those scenarios where you have a limited solution space, or if you have the finite solution space, or your exact solution might be present into the solution space. So there must be two conditions to use the search strategies. If your desired solution is present into the solution space and your solution space is finite, then you need to use the search strategies. If the solution space is not finite, is massive, and the exact solution might not be present into the solution space, then you need to go for the machine learning. I repeat again, in a real world scenario, if you come across with the problem in which you have the finite number of solution set and your solution might be present into the solution space, then you can use the search strategies. Like, for example, the eight puzzle problem, like, for example, the tic tac toe game. In all both examples, the solution space is finite and your exact solution is present into the solution space. Therefore, you can use the search strategies. However, if the solution space is not finite and your exact solution might not be present into the solution space, then you need to use the machine learning algorithms. There is a massive list of machine learning algorithms such as artificial neural network, k-nearest neighborhood, k-means clustering, decision tree, regression, naive Bayes, support factor, a priori, PCA, and there are lots of more algorithms that can be used in the machine learning. Then we have the deep learning. If you have a small amount of a data, then you can use machine learning, or by using the machine learning you can handle that data. However, if you have a big data, if your data volume is massive, then we need to go for the deep learning. That includes different algorithms like recurrent neural network, convolutional neural network, long short-term memory. We have different pre-trained networks in the deep learning. And additionally, we have the feature of transfer learning in a deep learning, which actually was not present into the machine learning. So to conclude this slide, you have three options for implementing artificial intelligence. Option number one, you have finite solution space and your exact solution is present into the solution space. Then you must go for the search strategies. If not, then you can go for the machine learning. Given that it has the small amount of a data, it's not actually the very massive and the big data. If it is so, then it is recommended to use or to go towards the deep learning. Pictorially, we can illustrate it as like we have a upper layer or the front layer, we call it artificial intelligence. This is the main phase that we look in terms of the artificial intelligence. Inside the artificial intelligence, if we look into the feature level intelligence, then that must be mimicked with the machine learning. Or if we need to have a massive parallelism, or if we want that your neural network or your deep learning network could extract the feature by itself, then we go for the deep learning. If we look in terms of the time, we can notice the first thing that needs to be noticed that artificial intelligence is the superset. Machine learning is the subset of artificial intelligence. Likewise, the deep learning is the subset of the machine learning. So you can say that in a big picture, we have artificial intelligence. Inside the artificial intelligence, or a subset of an artificial intelligence, we have the machine learning. And the subset of a machine learning is refers to as the deep learning. Generally, in artificial intelligence, we are going from a more generic intelligent system towards the more specialized and more specific uh, AI based system. If we notice progress of artificial intelligence with respect to the time. You can notice till 1980s there was no traces of the machine learning. The reason was very obvious that at that time we do not have much computing capability. There was no significant growth of information and communication technology. Our processing capability was limited. Our communication media was limited. Our storage capacity was limited. There, Therefore, we do not find any traces of machine learning during this era. In 1980s, then when we start having a significant growth of information and communication technology, we can notice the evolution of machine learning because at that time we have relatively better computing capabilities, better storage capability, better communication devices. But at that time, there was no traces till 2010. There was no traces of deep learning. The reason was the same because deep learning algorithm requires much comprehensive and much exhaustive computing capability. After 2010, now the current era is of a deep learning. So if we just look in towards the trend of artificial intelligence, so in modern days, in this current era, in this current era, researchers are mainly working towards the deep learning because it is more robust, it is more specialized, and it is more efficient in terms of the classical AI technique and in terms of the machine learning. Specifically, we can see that if we look a difference between the machine learning and the deep learning, a fundamental difference between the machine learning and the deep learning. In machine learning, we have the inputs attributes. We need a human expert that can extract the feature. And then, after extracting the feature in terms of the input attribute and output attribute, these input attribute and output attribute that technically we call as a data set. It is then forwarded to the classification network, artificial neural network for training, and as a result, it would classify the object. However, in the deep learning, there is no need of this human intervention. Deep learning network are a multi-layer network. These layers not only classify the output, but it will also extract the feature automatically. If we look with respect to the amount of a data and the performance, a very important thing that needs to be noticed that uh, on the x-axis we have the data and on the y-axis we have the performance. We can notice that for a small amount of a data, the performance of machine learning algorithm The performance of machine learning algorithm is found to be identical to the deep learning algorithm. Like in this area, you can notice these two curves are overlapping in this area. That shows that for a small amount of a data, The performance of a machine learning algorithm is very much identical to the performance of the deep learning algorithm. However, if the amount of a data increases, the machine learning is found to be constrained, and technically we call this phenomena as performance plateau. By the term performance plateau means by increasing further the amount of a data, there is no significant improvement into the performance of a system. On the other end, if we are using a deep learning, so by increasing the amount of a data, the performance of a system will be increasing exponentially. So we can say that machine learning algorithms are found to be deficient to handle the large amount of a data. Technically, we call it a big data. However, the deep learning algorithms are found to be efficient to handle a massive amount of data. So, this is a fundamental difference between the deep learning and the machine learning. The first difference is machine learning. In the machine learning, we need a human expert to extract the feature. However, in the deep learning, the network by itself extract the feature. The second difference between the machine learning and the deep learning is a performance of a machine learning is found to be constrained due to the performance plateau for a big data. But the performance of a deep learning is found to be efficient for a massive volume of data. If we look into what the researchers say about the artificial intelligence, the Ballman in early 1978 says the automation of activities that we associate with the human thinking, activities such as decision making, problem solving, and learning. This is called artificial intelligence. Furthermore, the Charnock and McDermott in 1985 say the study of mental faculties through the use of computational model is artificial intelligence. Another author, Dean, gives a definition of artificial intelligence as the design and study of a computer program that behave intelligently. These programs are constructed to perform as both a human or an animal whose behavior was considered intelligent. Another author says the exciting new effort to make computer think machine with the mind in the full and the literal sense. Another author say about the artificial intelligence, the art of creating machine that perform functions that require intelligence when performed by the people. Few more researchers have narrated about the AI, like Luger say the branch of computer science that is concerned with the automation of intelligent behavior, that is the human behavior. The Nelson says many human mental activities such as writing, computer program, doing mathematics, engaging in common sense reasoning, understanding language, and even driving automobile are said to demand intelligence. We might say these systems exhibit artificial intelligence. Rich and Knight say the study of how to make computer do think at which the movement the pupil are better. Another author said the field of study that seeks to explain and emulates intelligent behavior in terms of computational process. In 92, Winston said the study of computation that makes it possible to perceive reason and act. Based on these definitions by the different scholars into the literature, we come up with the modern definition that what is AI? It is a soft computing approach to make the system learn by training. It stores the knowledge and experiences, is classified the output, it predicts the behavior and the output, and finally, it optimizes the solution space for decision making. So, this is the modern definition in which we have the term soft computing. Now, it is important to understand that what actually is the soft computing. You people might be very much familiar with the hard computing. So, there is a fundamental difference between the hard computing and the soft computing. In the hard computing, a programmer needs to define the reaction or the outcome or the action by the machine for every input. Like, for example, if I'm making a tic-tac-toe game by using the hard computing, I need to define if user press this, then machine will do this or machine will do this. So there will be the set of the rule base. But eventually all the reactions must be programmed by the programmer, which is not actually feasible for such scenarios where the solution set is infinite. However, in the soft computing, we do not need to define each and every possibility. Like it evolved itself. So, in a plain words, if you can differentiate between the hard computing and the soft computing, in the hard computing, we programmed the system. However, in the soft computing, we trained the system. So, this is very important to understand that in hard computing, we program each and every possibility into the system. And in soft computing, we can train the system to deal with different uncertainties and imprecisions. We can use soft computing in different applications such as dynamic routing in routers, medical imaging system, voice identification system, image retrieval system, computer visions, decision support systems like such as the information systems or the e-doctors or the e-government. We can use artificial intelligence for semantic extraction from text and multimedia document. We can use AI for semantic web, for knowledge representation and reasoning system, for geographical information system. And there is this is not actually the exhaustive list. There are thousands and thousands of applications where you can use the term soft computing. So fundamentally, if you are going towards the field of artificial intelligence, that means you are going towards the area of the soft computing. Soft computing is actually a combination of the statistical method, analysis method, and the programming approach. So this is actually a blend of the statistical probabilistic model, a statistical model, and the programming. This is a combination. We call it as soft computing. If we differentiate between the hard computing and the soft computing, hard computing is a conventional computing that required precisely stated analytical model and often a lots of computation time. However, the soft computing differs from the classical computing that unlike the hard computing, it is tolerant of imprecisions. It can handle the uncertainties. It can manage the partial truth and it helps in approximation. In fact, the role model for soft computing is actually the human brain because human brain is not programmed, it is actually trained. Being a human, we are not programmed, we are trained. The hard computing is based on the binary logic or a Cliff's logic, one and zeros, yes or no, true or false. However, the soft computing can handle the fuzzy logic. The hard computing required a program to be written explicitly. However, in the soft computing, program can evolve itself with different iterations. It learns from the data and evolve itself. Likewise, hard computing is a two-value logic. On the other hand, the soft computing is a multi-value or the fuzzy logic. Hard computing is deterministic, that the response of a machine is deterministic. However, the soft computing is stochastic, probabilistic. Hard computing required exact input data. It cannot handle the imprecise or the noisy or ambiguous data. But soft computing can deal with the ambiguous and noisy data. Hard computing is strictly structured and sequential, but soft computing allows the massive parallelism of massive parallel computation. Hard computing produces precise answer, absolute answer, but the soft computing gives the approximate answer with the quantified error along with that. So this is actually the fundamental difference between the hard computing and the soft computing. All right, if we look about a data, we know that with the recent growth of information and communication technology, we have the massive volume of a data from information systems, from the online resources, from different blogs, from different repositories. We have the very bunch of data or available data which is available on internet. So the data is everywhere. So you might yourself notice the people are mainly data is like a fuel for modern day economy. It can be fetched from the sensor networks, from e-commerce, from social networking sites, from the websites, from the traffic analysis. We have the massive volume of data around us. So the modern idea about a data is gather a data, whatever data you can, whenever you can have a data, and wherever is possible you can acquire a data. And the expectation is sometimes we collect a data purposefully, and sometimes we uh, collect that data as well, which is not currently envisioned, but we are acquiring that data. So The point is, what actually is the advantage or rationale to have such a massive data? The reason is very obvious. The more data we have, more intelligent systems we can develop. So there is no point of collecting this massive amount of a data if we cannot translate that data into a actionable decision. Therefore, therefore, uh, we use this massive amount of a data to be translated into a more intelligent and more robust decision. This is what actually is the main point behind it, that why the main point behind it, why actually we have such massive volume of a data. There are the commercial point of view of the data, and there is also a scientific point of view of a data. The commercial point of view is it provides the better competitive advantage. Just a minute. It provides a better competitive advantage. Like if you have more data commercially, the company have more data, a company can have more uh, informed decision, a company can have the more intelligent decision. That decision could translate into the competitive advantage. In Pakistan, uh, as I've told earlier, I'm from Pakistan. In Pakistan, different bodies or different organizations commercially are using artificial intelligence, such as National Database, which is we call it a NADRA, Daraz, which is a online website for online web store, online. It provides the online commerce. Habib Bank Limited and different banks as well. Cream is a ride-hailing service. Uber, Federal Board of Revenue, National Bank of Pakistan, Al Khan University Hospital, Karachi Stock Exchange, Karachi Chamber of Commerce and Industries, and there are different organizations. This is only a small list. There are different organizations that are using artificial intelligence to translate their data into the more informed decision. There is a scientific point of view as well. Like we have a data that actually we translate that data as the experience to the machine. Like a data is technically we need to train the data, and we train that data by we train that data by means of some experience, or we train that model, we train that artificial intelligence model for different application, and for those applications essentially we need experience, and that experience we get from the data. So, in a plain words, you can say that for all the intelligent application, the data works as a experience that is given to the machine for training. Technically, if we look, we have a domain of statistics, we have the domain of artificial intelligence, machine learning, and pattern recognition. The blend or the common intersection is a data mining that has the power of artificial AI, and it has the overlapping with the statistics. The database technology, parallel computing, and distributed computing, they provide the foundation to those areas. Like if you notice in this diagram, database technology, parallel computing, and distributed computing, they are at the foundation. And statistics, data mining, and machine learning are placed over the database technology, parallel computing, and distributed computing. It means that there is a fundamental behavior that we call as a load and the support. This is statistics, data mining, AI, machine learning, deep learning. It is a load which is supported by the database technology, parallel computing, and distributed computing. If your support is weak, like if you have the weak database technology, if you have weak parallel computing, if you have weak distributed computing, then you cannot handle the data mining or AI. So in order to establish the intelligent system, you must have the good database technology, the modern database technology, the efficient parallel computing, and the efficient distributed computing. Technically, we classify machine learning into three different categories. One is called the supervised learning, second is called the unsupervised learning, and third is called the reinforcement learning. In a data set, I'm just giving you a very brief overview about that. If the output is labeled, then we can use supervised learning. If the output is not labeled, then we need to use the unsupervised learning. Or if we need to enforce the learning, then we need to use the third type of a machine learning, that is called the reinforcement learning. In a supervised learning, if your output is known and the output is discrete and qualitative, then we need to use the classification category of algorithms. There are different algorithms that are used for the classification. Or if the output is labeled, but the output is continuous, quantitative, then we need to use the prediction algorithm or the regression algorithm. Likewise, in a supervised learning, if your output is not labeled, then we can use clustering for classifying a data into the classes. We can also use different algorithms such as PCA, such as latent semantic indexing, and the other algorithms for reducing the dimensions of a data set. This will help to increase the computational efficiency of the algorithm. We can also use the Markov model for developing the policies in the reinforcement learning. So, in principle, there are three types of machine learning: supervised machine learning, unsupervised machine learning, and the reinforcement learning. There are different applications where you can apply artificial intelligence in modern era. This includes, but not limited to, personalized online store, smart cars, marketing, image enhancement, social media, surveillance, agriculture, customer services, video games, healthcare, bank, smart homes, virtual assistants, space exploration, and the chatbot. To give you a very interactive session, I can give you a demonstration of an application. We call it a teachable machine. A teachable machine is a platform developed by the Google to you can make your artificial intelligence systems without coding of it. Let me give you a brief demonstration of it. For that, I need to close my camera from here. Okay, now you can see on my screen when we say teachable machine. In Teachable Machine, we have three projects. We can have the image project, we can have the audio project, and we can have the pose project. Due to the time constraint, I'm just giving you a demonstration of the image project. If we click on this image project and standard image model, there are two classes. Let's say I call it with mask, and the other class is without mask. Now, I would train this system to recognize a person. It could be any person with mask and without mask. So let's first capture some data for with mask. Let's say I'm wearing this mask right now and taking some of my pictures with mask. Now I'm taking some more pictures without mask. Now, after acquiring these data, I would click on this train the system. As I've told you earlier, in a machine learning, we do not program the system, rather, we train the system. So, let's click on this training. It will take quite some time depending upon the internet connection. Moreover, the number of images. At this point of time, we take only 17 images for with mask and 14 images for without mask. So this is a very small number. But when you are training for some real application, the real number will be much bigger as compared to this number. So we have to wait for some time for the training to be initiated. While the training is in process, you should not switch your browser, or you should not switch your tab as well. Now the training has initiated. It is training. Now the model is trained. Now you can see. Now, at this moment, I am in front of a camera and it is recognizing me as without mask. When I wear the mask, it will automatically recognize me as with mask, like this one. So you can practice it at your end. You can use different classes. You can use different images to classify the images, or this is a trained model. Now you can export this model. You can export it on some TensorFlow. You can export it for some Raspberry Pi, or you can export it for some other embedded system, so that this intelligence would be embedded into the intelligence system. Recently, recently there is a tool, or the USB accelerator developed by the Google, and that USB accelerator is called Coral AI. This Coral AI, if we look into this browser, this Coral AI is actually a USB accelerator in which you can develop the model on some tools like Teachable Machine, and you can embed that model into the Coral. Let's back towards our presentation. Now, I would take this opportunity to share some of my research work in the area of artificial intelligence. This is only for the last 2 years, last year 2020, 2021. One of my team has developed, designed, and developed a valid new meta heuristic algorithm for mimicking the anonymous fish. Like there is a branch of artificial intelligence that we call as the nature inspired algorithm. The nature inspired algorithm uh, are actually a computational algorithm that are actually inspired from the nature process, because we understand that all the processes that are available into the nature are optimum at their level. So we just simply mimic, or we just simply reproduce those algorithms in terms of a computational model. And that branch of science is called a nature inspired algorithm. Mainly they are for the optimization, obviously. So we have a device algorithm that mimics the behavior of endomorphous fish, about laying their eggs, about their evolution, and then we validate that this algorithm is found to be valid or efficient for optimization. Another of my students have worked on the visual question answering. In this visual question answering, we use deep learning network to analyze the image, and then based on the contents of the image, it responds to the problem. For example, if you see an image of a seaside and you say, okay, what is the color of the sky? So this is a question from the picture. So the visual question answering respond about that picture, that the color of sky is this. So visual question answering is the recent branch of a science that says how to interpret the visual images into a text. We due to this pandemic, we found a data set of face mask, and we have devised a deep learning method, and we call it as a ParkNet. ParkNet is for Pakistan Net. We develop a model named ParkNet that can recognize or detect the incorrect mask wearing position. Like there is a model that can analyze that either you have wear your face mask correctly or not. We have also used machine learning method to detect the Parkinson disease into the patient. Like this would be a supporting value addition to the doctors so that they can analyze about the Parkinson disease, that either a particular patient is infected or is suffering with the Parkinson disease. So we use different machine learning algorithms for comparison, and we have devised an algorithm for detecting the Parkinson disease. We have also proposed a new algorithm, and we call it a fractional order approach to predict tensile yield strength of a polyethylene. There is actually a test we call it a tensile test in the industry to analyze the yield strength of a material. So we propose a non-destructive analytical testing of a polyethylene pipe by using the machine learning algorithm. We have also developed a deep learning ensemble deep learning network for musculoskeletal disorder classification. Like we have the data set of musculoskeletal disorder, and we by using the deep learning method, we classify the musculoskeletal disorder. We have also used deep learning, and we develop a hybrid ensemble fusion of deep learning approach for chest radiograph classification. So these are some of my research work that are submitted for publication. Other than these research work, I do have some other research publications which are actually published, and you can find these are my 18 research publications, journal publications, are around 20. This is some numbering issue with the sequence. There are actually the 20 research publications in the duration of 2019 to 2021. You can find all these publications on my Google Scholar. Like, let me show you. If you go to the Google Scholar, you will find with the name dr.Sajjad and Rizvi, and there is the list of publication available here. So you can download these publication from this my Google Scholar link. I'll give you a brief overview about this work. The first one is the optimum machine learning model for Kitsune to detect the Mirai botnet malware attack. There is a tool which is called the Kitsune for network intrusion detection. So we use optimum machine learning model to detect specifically the Mirai botnet attack into the network intrusion detection system. We also use adaptive federated machine learning based intelligence system for skin disease detection. We use machine learning algorithm, specifically the artificial neural network, to predict the delinquency on the mortgage loan. We also propose a novel image-based framework for processing, monitoring, and fault diagnosis of the mooring lines. Another work on the image and image processing and the artificial intelligence. We have novel context aware pixel abstraction for the image, semantic segmentation. For the constraint ending technique, we have proposed a novel constraint ending technique for a fast conversion. Our research work was comprehensive performance evaluation of network intrusion detection using the machine learning approaches. We use hybrid heuristic approaches for miniaturization of a monopole patch antenna with the extended UWB spectrum. We have explored the data mining for the role of FCBF feature selection algorithm in education data mining. We have the machine learning classification model for scanning and DDoS attack. We use big data analytics for concept drift detection in one of our research. We have a study for the feature selection algorithm for predicting the student academic performance because, as I've told earlier, the machine learning algorithm are found to be very dependent upon the set of the features. If the features are not very comprehensive or very fruitful, it will degrade the performance of our system. So we have proposed the feature selection algorithm. We have proposed the machine learning based channel equalization for filter bank multi carrier communication. We use deep learning for object detection technique for thing object in computer vision. In one of our research, we have used the parametric evaluation of a deep learning network for musculoskeletal disorder and a new variant of a deep learning for chest radiograph. We use novel approaches to detect the constant drift using the machine learning. Uh, there is a survey on the constant handling technique for the nature inspired algorithm. We use a survey on edge detection based recent marine horizon line detection method and their applications. We use a parametric comparative evaluation of a machine learning algorithm for Google Play Store. So, this is a set of publications. You can go to my Google Scholar and you would find those publications. So this gives you a direction towards the artificial intelligence. Like if you want to pursue your career into the area of artificial intelligence, you can apply it for network intrusion detection. You can apply it for biomedical. You can apply it for banking sector. You can apply it for loan prediction forecasting. You can apply it for pathological tests uh, classification. There are numerous applications where you can apply the artificial intelligence for the real time decision making. So this is all from my side, and I'm very thankful to the Nile University of Science and Technology for giving me this opportunity. And I must appreciate the efforts of Mr. Mohammad Mustafa for establishing a very fruitful and very active collaboration with the global universities around the Pakistan, around the world. And inshallah, we are planning to have such collaboration between the Nile University of Science and Technology with some renowned universities in Pakistan. We have also discussed about to have or extend this academic collaboration not only for the Pakistan but with the other universities around the globe. So this is something very appreciable, and this is something very motivating for the students that they would benefited from the global experience. They would have the better comprehension of the contents because in the current era of information technology, now we are not restricted to the classroom study. We can think beyond the classroom study. We can think out of the box. So thank you very much, and now just see if we have some questions on the portal. There are welcome, best seminar. Thank you, mashallah. Share video. Sorry, I cannot understand it. Connect. Hope you are again there. Nile University. Dr. Thanks for the great work at Nile University. We provide excellent future environment. Thank you so very much. Hope you sorry, I cannot understand this language. Uh, Thanks. Okay. Now let's see if we have some questions on the Facebook. On the same comments are on the YouTube. Okay, Ji, thank you so very much. This is all for today. Uh, I would request Mr. Mohammed Mustafa. Mr. Mustafa, can you hear me?